This is an inserted preface to the original video I recorded for this program. I recently added a new leverage analysis method called MHMCD75. It will not be mentioned on the original video, but it will show up as an option in the current program. The standardized OP method is generally preferred, but if you have dummy variables in your predictor set and you want to include them in your leverage analysis, use the MHMC75 option. I'll now start the old video which provides you with the basics of executing this program. In this video I'm going to show you how to use the leverage analysis program. It's in chapter 6. I'm going to come down and click on the button for it. And when I do so, the text for the instructions appears in the description box. This tells you everything you need to know in order to use the program. I'll be inputting data into the input values for leverage analysis. Because I use raw data, I have to get the raw data file. So I'm going to click on Choose File. This is in the C drive in the folder RET. And I'm going to go down and find the data file I'm going to use. For this one I'm going to use temp.dat, and I open it. And then this shows the names of the variables in the file. This is very important for me because I have to reference some of these variables in the input box, and R is case sensitive, and I need to be very careful about being accurate, not only in terms of the content but capitalization. Up here I have to put the full path for the data, including the folders, so that the computer knows exactly where to go to get the data. So I do that there. Most of you know about outliers. I've heard the concept of outliers, but actually statisticians make distinctions between outliers, which are highly deviant cases on the outcome variable that deviate considerably from the regression line, and leverages. And leverages are unusual scores in the predictor space. It only focuses on the predictors. And it turns out that the impact of an outlier on regression coefficients and the like is a function not only of how far it deviates from the regression line, but also its leverage score. The impact is essentially a multiplicative function of outlierness and leverageness. There are some robust methods that, like trimmed mean regression analysis and quantile regression analysis, that protect against outliers, but they don't protect against extreme leverages. And the current program is designed to identify unusual profiles of scores in a predictor space that you then might need to act on if you use a regression analysis like trimmed mean regression analysis or quantile regression analysis. I'm going to go here and identify the ID variables so that it can identify cases that are extreme leverages. And then here I'm going to list the predictors, comma delimited, that will be in my regression equation. And for this particular example, I'm going to have 3 mediators that I use. The actual content itself doesn't matter that much. I'm just trying to illustrate the program. And the last one is extern 2. So these are 3 mediators that I'm going to be using in a regression equation ultimately to predict an outcome variable CR3 from these. And I want to see if there are any cases with unusual scores on the multivariate profile of these 3 predictors. I'm going to click Register Input. That generates syntax that will do the leverage analysis. I copy that to the clipboard, and then I'm going to open up R and run it. This is R. I'm going to use Control V to paste it here, and the output will come up from that. This analysis identified 5 cases, and these are the cases that have extreme leverage. If I'm using trimmed mean regression or quantile regression, I would want to do analyses both with and without these leverages and see if my results are affected by that. I will show you in the trimmed regression mean program how to eliminate the cases from the analysis. So you can check that video to see the process. Okay, so I'm going to close this. Now, one other thing I want to mention, in the book, I discuss the two different methods for doing leverage analysis. Both of the two methods have strengths and weaknesses. The MGV analysis is probably a little bit stronger, but it's very slow in terms of running. It's process intensive. The outlier projection analysis tends to do a very good job also, but it'll run much faster. So I recommend, if you have time, to probably use the MGV, but the outlier projection method is very serviceable. A final point I want to make is that I use these methods because they rely on robust identification of outliers. Some people use the Mahalan-Bosch-D or HAT statistic to do so, but these techniques are problematic because they're influenced by the very outliers that they're trying to detect. It's better when you do outlier analysis to use robust methods, and that's what these techniques are. Okay, that's it. Thanks.